Hi, Statistics student. This video is for chapter 8.2, part 2, about continuing with finding confidence interval for population mean when sigma is not available. And we go over in part 1 that we would have to depend on t distribution because t distribution can help us to find the tick mark that would have a tail area at the end when s over square root n is the tick mark instead of sigma over square root n. And I was working on this second example where I want to find out how many, like when people take this uh, prescription drug called sopicolone, what is the population mean time for all patients that take it? Because 16 subjects had a mean wake time of 98 minutes at night, and the standard deviation is 42, so they deviate a lot. So what is the actual mean time for all patients that take this? So we collect all the information. We're in the middle of finding. Well, I think we find the critical value using inverse t calculator. It is t because no sigma, right? So the information we have is only n, x bar, and s, and sea level, and no sigma. So you have to use t. So t is 2.9. Now we would just construct the confidence interval. Now you don't have to construct t. I just want to go through this so you know that, okay, so this to do 99%, the number of tick mark is 2.9. It's not, 2.3 from Z or whatever. Because if you do Z, let's look at, if I am actually doing inverse Z, 0.99 is 2.5 only, right? Because the tail is smaller, so that would be 1%. But for a inverse T, for a degree of freedom of 15 and 99% is 2.9. So there is a difference. Um, but to construct the confidence interval, you just go to Statis, and we were working on it last time, and then the recording cut off. So I have put in 0.99, I have put in sample size, I put in sample mean, I put in sample standard deviation S, but no sigma. So don't put anything, and I do evaluate, and this is the answer. The margin of error is 31.16, and the lower limit is 67.74 if I do 2 decimal places. And is from 130 people wake up 67 minutes up to 130.06 minutes. So because the standard deviation is really big, so use confidence interval mean, and then your the margin of error is 31.16 minutes. Then meal would be how many minutes? 67.74 minutes up to high upper limit is 130.06 minutes. Okay, at what? 99% confidence sea level. So can we conclude that the mean time, the wake time is less than 100? Because in our sample, we have 98.9, which is less than 100. Is it? No. We don't look at X bar. We look at the interval. The intervals say that it can be as high as 130. It's not less than 100. There are a lot of number that's not less than 100. So we say no. Okay. A lot of values in these confidence intervals are more than 100. There are some that are less than 100. So it could be, but we cannot be 99% confidence at 99% confidence. And the next one is if confidence level is decreased to 95, I don't want to do 95, what would happen to the margin of error? So the only thing it changed will be T, right? So if C level is changed, decrease, T will decrease, right? Because the middle percentage is only 95%, so of course your T, So compare 95 smaller, compare with 99, which is wider outside. You can see that this is much larger number. So this t would be smaller. T smaller means E is smaller. Your interval would be smaller. E, list below amount of arsenic. So these are data, right? We have some data from California and assume that they they didn't say that they are normally distributed, and we have such small sample, right? Can we be sure the X bar is normal? Right? Can we assume the amount of arsenic in brown rice from a normal distribution? If it is, then I don't have to worry that I have to have large sample size. So what can we do? We would use normal quantile plots for normality assessment. So I have my data here in a column. I copy it and I paste it to Statis. Clear all this, reset the browser, and put in here, Control V. And then after that, then you say, okay, let's do normality and assessment, column 2. So fail to reject normality, that means it's normal, right? So we have such small data, n equal to 10. So histogram is not reliable. You primarily look at your line, your quantile plot. The quantile plot is quite good. They don't fluctuate a lot because you only have 10 points. But the most important thing is they say fail to reject normality, and there's no outliers. That means it is normal. And we can conclude that the so we can assume population X is normal. So if that is the case, X bar is normal, and we can construct the confidence interval, and we want to construct 90% confidence interval. Should I use T or Z? We would use T because sigma is not known. We only have data, nothing, right? So no sigma, so use T. So let's see. So what sea level are we doing? Our sea level is 0.9. We move the data into Statis and we'll just do it. Okay, so go back to Statis. After we do this, we would do analysis, confidence interval, mean one sample, but we use data. And it is it 0.9? What was it? 0.90. Okay, 90% confidence interval. So we say 0.90. The column is column 2, and I don't have population standard deviation. So all we have is here. Our error is 1.34768. Lower is 5.00. Upper is 7.697. Yeah. 1.348 for error. Yeah, so this is what it is. Okay, so that's how you do it. Now, in case you don't have the data, you have a comma list. So what can you do? There is another calculator here. From LibreText, there's a confidence interval calculator for population mean with data sigma unknown, and you can just put your data here. So I'm going to try to see if I can copy the data. I think I have to close this first before I can do copy and paste. Copy. And then do Control V, I guess. So these are all in comma form, right? There's some backspace. Okay. And then we'll have to do 90% interval, and that's all you enter your data and your sea level, and you calculate. So it's good that they in this calculator they actually calculate X bar for us and they calculate S. So but they don't have E. So our lower bound is the same, right? 5.002, 7.697. It's exactly the same. But it's good that they have X bar and S, but they don't have error. The margin of error. So I think different calculator have the different pros and cons. Okay, let's continue with the other example. So if you want to, you can use the LibreText calculator. All the links are on Canvas. Okay. Now, I also want to find critical value. In case I want to find critical value, what do I do? Because sigma is not known, I use the inverse T calculator. I have, how many data do I have? I have 10 data, I think. Right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So degree of freedom is 9. It's quite sea level is 90. So let's try it. I calculated before, so it's 9, 90, 1.833. 1.833. So that's what you do. Interpret the meaning of the confidence interval. So we say we estimate with 90% confidence that the mean amount of arsenic is between 5 microgram to 7.7 microgram, or 90% of all confidence interval collected from a sample of size 10 will contain true mean arsenic. So you have one intervals that you calculated, so this may contain your meal, but 10% of them don't. Okay. Can we conclude that the mean amount is less than 8? Let's look at this. 5 to 7.7. If you draw the number line, the real mean is from 5 to 7.7. All of these numbers, so this is a meal, all of this is less than 8. So we say yes, right? Because 8 is greater than any single number here. Okay, so the last things we want to talk about is now, because sigma is not known, we cannot do sample size estimation. Like we cannot determine sample size if you want a certain margin of error. The sample size determination has to depends on sigma. So we don't have those kind of question, but we can look at sample size, margin of error, and sea levels relationship. So because E is T alpha over 2, S over square root N. If N increase, E will decrease, right? You divide by more number, so E will decrease. That means the interval will be shorter. Critical value T will increase when sea level increase. So E will increase when sea level increase. So if your sea level, you use 99, then your error will increase. So there is a interactive activities that is available in LibreText. Do I have it? Maybe I'll just look at this one. I think I don't have it anymore. So there is an activity that you can see visually compare the effect of changing. Yeah, this one. So maybe we'll do it in class also. The effect of changing the confidence level and the sample size. So right now, how does this work? Oh, okay. So if you change your this is the sea level. The sea level is 63, which is too low. So let's at least have 90 and 94, right? So if I change it to 99, you see how it is wider, right? Wider. Really wide if it is 99. And so if I fix at 95% or whatever, and then I change my sample size smaller, they will be much wider. But if I increase my sample size, the confidence interval lower upper is smaller. This 0 is where your population mean is. Okay. Okay, so if you can see that your population mean is almost in all of the interval, right? But if you change it to smaller, like 90, all of a sudden you can see that, oh, this interval doesn't have the meal, right? This one is almost missed the meal. And if you change them, if you make them smaller, then there are more chance that you collect this interval, but actually it does not cover the meal. Okay, so we can play around with this in class to look at how they affect each other.